Good morning, everybody. Having trouble figuring out, I think I really want to be standing there. Anyway, I'll try to be mobile so all of you will get to see at least a little bit of me all throughout the morning. So I'm very pleased to see all of you here. I'm going to be talking about some work that I've been doing that I want to share with you. But before I get to that, I owe you an apology. I have nothing to show. I have no demonstrations. I have nothing to give you. I have no code. I have no documentation. There's nothing you can take away from this. And worst of all, if what I'm about to share with you is of interest, there is no way at this moment that you can contribute. And that's inexcusable. My excuse is that I was invited to talk about anything of interest to me, and this is really interesting to me, and I hope it'll be really interesting to you as well. So I'm going to be talking about the web. You all know the web. The web is what informs us, it's what feeds us, right? It's what distracts us, it's what frustrates us, it's all the things that the web does. And I've been thinking a lot for many years about what's wrong with the web and how we can make it better and the difficulty of making it better. And by better, I don't mean just some abstract notion of betterness, because we need something more tangible or more specific that we can be concerned with. And the biggest concern I have about the web and its current architecture is its security. That the web was not designed to be an application delivery system. It was designed to be a simple document retrieval system. And as such, it does not have in it the foundation that we need in order to have secure applications. And so we're constantly dealing with XSS crises, and other sorts of problems. And everything we do has the potential of compromising us or our customers or employers or clients at any time, which is scary. And so I've been thinking about how do we fix that. If we look at the security of this stuff and where it comes from, one of the most important things we have to consider are passwords. Now, looking at the history of passwords, the first computers did not have passwords. Anybody who could get to the machine could make the machine do anything the machine could do. The first computers were guarded by men with guns, literally. That physical security is what made those systems secure. And that passwords on computers had no value until we got disk drives. When disk drives were invented, we now had online storage, and that meant that there was something in the machine that was worth possibly getting at. Passwords become really important when time sharing happens. Time sharing was the first computing as a service in which you would buy time on a machine, and you would access it usually through a teletype. And the time sharing systems needed to be sure that whoever was connecting to it was authorized to use the account that they were using and that they were going to be paying money for the time that they're going to be using. And they used passwords for that. And passwords worked because generally you would only ever have one time-sharing account. And so you'd have one password. A human can remember one password. Then we start going onto the web, and on the web, every site needs to have a different password. That if you share passwords among different sites, it means that if any one of those sites is corrupted, then all of your accounts on all sites are lost, which is a terrible thing. And so it means you need to give a different password to every one. But people cannot remember that many passwords. We know for a fact that humans cannot manage passwords well. And the more passwords you have to manage, the less likely you are to do it. And so one of the big problems we have with passwords is it is surprisingly easy to trick someone into revealing their password to someone they shouldn't be revealing it to. And that's something that goes on all the time, and it's something that we should be worried about all the time. And it's sort of fundamental in the nature of the web as we currently use it. So if, this RFC 1738 was the first document which described URLs. That standardized URLs, or proposed a standard for URLs. And that document included a particular format for a URL that included a username and a password. And that password would be sent from an agent to a server in the clear. Now, at least one of the authors of that RFC recognized that this was a problem, and so he inserted this sentence: the use of URLs containing passwords that should be secret is clearly unwise, which was an amazing bit of understatement. It's way stupider than that. But they had nothing better to propose. I mean, why do you put something like that into a standard if you know there's a better alternative? They didn't have a better alternative, so that's what they got. We don't use this feature, but some people did. They saw it in the RFC, and they ignored the warning, and they found out why it was really unwise. So that's sort of where it started. So my proposal is we've got to fix the web. But before we can fix the web, we have to take a really hard, serious look at what's wrong with the web. If we don't understand what's wrong with it, how it's deficient, how it's broken, then we're not prepared to make it better. Now, most of us have never worked with any other architecture. We've only done web and nothing else. And so you define yourself in terms of the web. The web is what you are. And so what I'm about to do is going to be shocking and upsetting to a lot of you. That I'm going to be attacking this thing which is fundamentally a part of your own definition, your own livelihood, your own life. But it's all true, and we need to face this if we're going to make it better. So the problems with the web are that it's insecure, and that we need things to be more secure in order to better do all of the things that we need to do and to give service to all of the people that we're trying to serve. And much of the insecurity of the web is due to its complexity. The web started off as an amazingly simple system, a distributed document retrieval system, but over the years we've added more and more and more layers and layers and layers, adding more and more standards and standards, never removing bad stuff, always adding more stuff, some of it good, some of it bad. But that just creates overwhelming complexity, and that complexity itself is the cause of a lot of the insecurity that's in the web. And that's not something that can be corrected by adding new standards, because new standards, all they can do is add more complexity. They cannot remove complexity without causing breakage. And we don't want to break the web, and so the web continues to get more and more complex, less and less secure. So let's look at the individual components of the stack and understand their relationship to this problem. We'll start off with HTTP, the Hypertext Transport Protocol. It was designed for moving documents, or for requesting a document from an agent from a server, and the server delivering the document, then disconnect. That's the end of the transaction. And for that purpose, it works really well. But modern web applications aren't like that. You don't go to a server and request one thing and then disconnect. You end up asking for dozens of things, maybe even hundreds of things in some cases. But this protocol wants to request one thing and wait for it to come back before you can ask for the next thing. And that adds a lot of delay. And so browsers have instead come up with a technique where they'll open up several channels to the same server at once, so that they can get stuff over all of those channels, so that they can try to factor out a lot of the delays that are caused by HTTP being so inefficient. HTTP is also a container of key value pairs, and it's sort of an eccentric format. There are much better formats for doing key value pairs, JSON, for example. And it also does negotiation. So in the early browsers, they all had different capabilities. And so they could ask a server for something that, they might want to do certain kinds of images, but they don't understand JPEGs yet. That actually happened. And so the browser and the server, through HTTP, negotiate what kind of content to deliver based on what the agent seems to know how to do. That was probably a really good thing in the early days of the web. Today, not so good. Everything is fully capable, and we get automatic updates all the time. So that's adding a lot of overhead and inefficiency to the protocol without much value. Then there's DNS, the domain name system. This was created as a convenience so that people did not have to remember IP addresses, because an IP address is just a bunch of numbers separated by dots. Humans are really bad at that kind of stuff. So DNS provided a mechanism by which we could give those things names, which was a nice thing to do. Unfortunately, it is not compatible with the trademark system. And so we see litigation and other problems going on all the time as a result of this fundamental incompatibility. Worse than that, DNS is subject to its own security problems. There's domain squatting, there's misdirection, there's DNS poisoning, and lots of other things, so that typing in a name does not guarantee you that you're actually going to get to the IP address that you thought you were going to get to. Whenever you have those sorts of confusions or those sorts of indirections, there's a chance for insecurity. There's SSL, the secure sockets layer, that was developed by Netscape. Netscape recognized that we're trying to do commerce over the web, but HTTP has terrible security properties, and so we need to boost it up. And so they came up with SSL. SSL was a good idea, but fundamentally wrong architecture. It turned out to be way too complicated, and as a result of that complexity, we are still debugging it. It's been, almost 15 years now of SSL, and we are still routinely finding huge security blunders in SSL. We want to be having some kind of infrastructure which, over time, the number and severity of bugs goes down. We're not doing that. SSL is not converging on something which looks to be correct and good. One of the fundamental problems with SSL is its dependence on public key infrastructure and certificate authorities. The idea in SSL is we want to have a certificate which indicates that an address belongs to or represents some identity. And a certificate authority produces a set of bits which designate that that's true. And so you've got certificate authorities like VeriSign who will issue a certificate, but all a VeriSign certificate really tells you is that somebody gave money to VeriSign. It doesn't really tell you anything else. That we've seen VeriSign has been hacked. We don't know what goes on there. Is it possible to get a bogus certificate out of VeriSign? It has happened. It may be happening right now. We don't know. And the fact that we don't know makes me really, really nervous. But worse than that, there are hundreds of other certificate authorities who your browser trusts equally, and many of them have already been compromised and can issue bogus certificates which your browser believes are real. That's a really bad thing. And it turns out the whole thing is unnecessary, because the whole point of having these certificates is the idea is that the certificate can be validated offline. But we're online. Everything we do is online. So having an offline verification system doesn't buy us anything. And in fact, we often have to go online when using the certificates in order to determine have they been revoked. So it's all completely convoluted and really expensive, and it is not secure. HTML, the hypertext markup language. Is HTML a good thing or a bad thing? It depends on what you're doing. If what you're doing is trying to mark up a simple technical document, which is the thing that it was designed to do, it's really not very good. It's a very fussy notation. It's hard to write. It's ugly. It is really fussy. If you get anything wrong, it can go bad really quickly. That's why we invented Markdown languages. Markdown languages do the same thing that HTML was designed to do, but are so much nicer. They're much easier to use. They're much more likely to produce stuff that is correct. So HTML is not very good at that. Now, suppose what you want to do is deliver interactive applications over the web or over the internet. HTML is really awful at that. It was not designed to do that. And we're making it do it, and mostly due to a lot of extremely clever people like you. You have all figured out ways to make HTML work for you despite its shocking limitations and omissions. You're ingenious at the way that you're using this thing, but it's compromising you all the time because it doesn't want to do what you're doing, and so you're forcing it constantly, and that's most of what you're doing. It's a struggle. So the thing that I like least about HTML is templating. Templating is a practice in which we will take some data and we'll take an HTML template and we'll insert the data into the template and then send the template to the browser. This turns out to be a really bad practice for a number of reasons. The first one is that it is the root cause of XSS injection attacks. That it is possible in templating to correctly insert text into a template and not cause security mishaps from doing that, but it is way too common for stuff to slip through and cause harm. And it's because it's something that's constantly waiting to compromise us. It's hard to code correctly 100% of the time, but you have to code it correctly 100% of the time, and if you ever don't, you get an XSS attack. And the consequences of those attacks can be really terrible. The second thing I don't like about it is that it causes a fixation on HTML. And this fixation ends up infecting every layer in the application stack, so that everything is focused on creating HTML, going all the way back to the database, that your database design is all about HTML. And it becomes so invasive that you can't see how to do anything correctly or efficiently, because that's not the problem. The problem is everything has to end up in HTML. So it really constrains the way you think about things in a not good way. Then the third thing that I like the least about templating systems is that it's a trap. If everything is about templating HTML, you will never become free of HTML. You're stuck in that forever. There's no escape. And I would like to provide you with better options, but we can't as long as we're in this templating mode. The document object model, or the DOM, is the API that the browser presents to JavaScript for manipulating HTML content, and I think it may be the worst API ever imagined. It's just really awful. It's at the wrong level of abstraction. It's leaky. It's weird. It's not portable. It's buggy. It's horrendous. It causes enormous pain to you and the people you work with. It's just awful. But that's where we live. That's where we spend most of our time every day, and it's just awful. And to make it worse, it's insecure. If a third party can somehow get access to any node, they can chase that node back to the parent, to the root of the document, and that essentially gives them all the capabilities of the browser. It's not a secure system at all. Then there's CSS, crappy style sheets. So CSS was designed for doing formatting, textual formatting of simple technical documents. But that's not what we're doing. We're doing sophisticated applications that contain lots of modules, lots of components, sometimes coming from different partners, that all have to work together. And CSS was not designed to do that. There are some flows and layouts that CSS still doesn't want to do, and the ones that it can do require a tremendous amount of hackery. There's generally not a straightforward way of doing most of the things that you want to do in CSS, and so it's a constant battle with it. Also, it's incredibly fragile, that someone can stick a new rule into a CSS system and suddenly everything breaks. And that fragility is a really difficult thing to manage. And so sometimes you see sites where the CSS keeps growing and growing and growing because everybody's afraid to take stuff out, because who knows what's going to happen. Everyone's afraid to refactor it because if you change any rule, suddenly everything breaks, and it just keeps, that's not scalable, right? Eventually that leads to total failure. Then there's JavaScript. So JavaScript is still the world's most misunderstood programming language. JavaScript is a hot mess. There's a lot that's wrong with it, but there's a little bit that's right with it, and that rightness is enough. And so JavaScript is the the universal workaround system, that everything that's wrong with the web, we fix it with JavaScript. That's how we make it work. That's what this stuff's all about. So we spend all of our time using JavaScript to work around problems in the web. That's what we do. If you call yourself a web developer, you do workarounds in JavaScript. That's your job. We've been working around so long that it's easy to lose sight that that's what we're doing. We're working around, that there's not a straightforward way to do any of the stuff that we do. Everything's a trick. Everything's a hack. This is way too hard. But worse than that, there are some things that are broken in the web that JavaScript can't fix, and that's the security problems. That JavaScript tends to amplify the security problems that are in the other components of the web, and itself increases the danger by having global objects and other sorts of global dependencies, which are also insecure. But that's what we're working with. And so JavaScript has surprisingly become one of the world's most used programming languages, which is not something that anybody ever expected. Certainly not the guy who designed it. I don't think he ever thought that would happen. I think he's a little embarrassed that it happened, because now everybody's looking at his work and going, but he actually got a lot right, and that's why we're still talking about it and why we're still stuck with it. So many have recognized that there are all these problems in the web, and they are real problems, and these are not new. You know, what I'm talking about is not, hey, we just found this out. We've known this stuff from the very beginning. And it's only gotten worse since the beginning. So a number of companies saw, well, there's an opportunity here. There's so much that's wrong with the web. We need to figure out a way to replace it. There's a big, we can make a business out of this. And so Microsoft, Apple, Adobe, Oracle, and many other companies, big and small, have all tried to go after this. In most cases, the technology they came up with was much better, at least in some dimensions. In most cases, the solutions they were talking about were not open, because what they were all trying to do was to capture the web, to take all the opportunities that the web provides and bring them in and make it a proprietary thing. So, so far, all of those attempts have failed. And I think the reason they failed wasn't because the technology wasn't good enough, but because they did not have a transition plan. Now, in some cases, the technology was not good enough. Well, in fact, I would say in every case, because none of them considered the security problems that the web suffers from, that they all came up with solutions which had even greater security problems. Because it turns out, despite all of the big problems with the web is a more secure application delivery platform than all of the others, including all of the systems that were designed after the web. And these guys all failed to learn the lessons of the web. But that's not why they failed, because we have seen lots of cases where a technology can become popular without being secure, and then you have to live with the consequences of that. The reason they failed was they didn't have a transition plan. They didn't have a way that they get from the open web to their closed proprietary whatever it is. They just couldn't figure out a way to get everybody from here to there. Their plans were always to try to trap you, to try to get all the web developers, seduce you into working on their platforms, and they thought that would do it, and it didn't do it. So my plan is not to replace the web, not to capture the web, but to upgrade it, to make it better in ways that we need to make it better, not just adding new features and new standards, but fundamentally fixing the things that are broken without breaking anything else. And that turns out to be a really difficult thing, but I think it's manageable. And the critically important part of it is the transition plan. How do we get everybody onto the new web in a way that makes sense? And my metaphor for how to accomplish that is HDTV. So we have all been through the HDTV transition. Just a few years ago, we were using analog TV. Anyone remember analog TV with the snow and the ghosts and anybody remember the hard channel clicker? Any old guys maybe? Yeah. That's gone. And we got rid of that in a remarkably smooth way. It wasn't known at the time that it was going to go so well and so smoothly. In fact, Congress and the FCC were really worried that the transition wasn't going to go perfectly, and that there was a real concern that if they switched off analog TV on January 1st, if people aren't able to watch the Super Bowl, there's going to be armed rebellion and a march on Washington and all of that. And that didn't happen because the transition worked. And the reason the transition worked was because they came up with a device that made it work called the set-top box. TVs used to be great, big, huge boxes, so big that you could take a smaller box and put it on top of it. The old people remember that, right? And the box could do lots of different things. It could be, it could talk to your cable system or your satellite system, or it could, in this case, be something that had a digital receiver in it that would convert the signals to analog so that you could watch it on your old TV set. So in the United States, Congress made funds available so that low-income people could get these boxes for free or for very cheap, and that would allow them to watch stuff as the broadcasters switched from analog to digital. And so from the perspective of the public, they didn't see the transition. That while it was going on, they didn't know if they were watching analog channels or digital channels. They might have observed that the digital channels were much slower to tune. You know, you go click and it takes a while for the thing to show up, but it eventually does. And when it does show up, it's going to be a much better picture. You don't get the snow and the ghosts and everything. It was much clearer. But that was all. And so the focus for the TV transition was on the audience, and it worked. The focus was not on the broadcasters. In fact, the transition was extremely expensive to broadcasters because it meant they had to buy all this new digital equipment. They had to be broadcasting analog and digital at the same time, which increased their utility bills. And there was no new revenue to offset that. And it didn't work for producers of programming because they now had to be buying new equipment and building better sets and doing better makeup and better costumes and all this stuff. All of their costs increased, but the money that they could make doing this program did not increase. So it was a hardship on them too. So it wasn't good for the publishers or the developers, but it was good for the audience. And that's the thing we need to focus on. We need to figure out a way to make a new web or an upgraded web that works for the audience. So the set-top box in this metaphor is the helper app. Anybody remember helper apps? A couple of the old guys. So when the first web browsers became available, they were pretty incompetent. There was a lot of stuff that they didn't know how to do. They didn't know how to display all of the hot new image formats, like they didn't know about JPEGs and PNG files. They didn't know how to play audio. But what they could do was you could designate that when a particular file type appeared or a particular protocol was asked for, and if the browser didn't know what to do, some other application will get started. And so the browser could start up a paint program, and the paint program knows about JPEG, and so it could display it. And that allowed us to have JPEGs while we were waiting for the next version of the browsers to get it installed. The helper app mechanism is still in browsers. We just don't use it anymore. But I'm proposing for this exercise that we bring it back into use again, because that's going to be our transition strategy. We're going to make a helper app which has the new stuff in it, which makes it available to everybody without having to fix the browsers first, because starting with changing all the browsers at the same time is way too hard. That's not a good transition strategy. So this is my transition plan. So step one, I need to convince one progressive browser maker to integrate the helper app into their browser. This should be an easy thing for them to do, because the helper app, all it needs from the browser is a rectangle that it can put its pixels on. It needs access to UI events, and it needs some kind of messaging channel so it can send JSON messages from the helper app to the browser and back. So really simple. If a browser can do those things, they can integrate the helper app and it becomes standard equipment. And that's really important because most humans will not install a helper app. Hipsters like you can do that, but nobody else is going to do that. So you can download the helper app and see if it works and see if, well, this is desirable. I think my clients could really benefit from this. And then we need to get it into the browsers, because only if we get it in the browsers will the users use it. So the first step is we'll try to convince one of the browser makers to take this step. I'm guessing it will probably be either Firefox or Microsoft Edge. Generally, Firefox is the one that gets ahead of these things and will do the new thing first, or Opera also is very much getting these things first. Microsoft has recently gone from being the stodgiest and slowest moving to the most experimental. So they might be in a mood to do this. So we only need one of them to be the first. If we can get three to be the first, that would be great. But one will be enough. Then we need to convince one secure site to say for some purpose, for some service, people have to be using this new browser in order to access it. That the security requirements are so important, we're doing banking or we're doing funds management or medical records or something that's really critical that needs to be secure, and we're tired of being compromised by XSS attacks, and so we say, you got to use this. It's that important. Then risk mitigation will encourage lots of other sites to do the same thing. So eventually we'll get all of the banks, all of the retailers, everybody who's dealing with money or privileged information, everybody who's really concerned about security, which should be pretty much everybody, will want to be doing this because it allows them to provide a much higher level of service with much less annoyance. So we'll do that. And once that starts to happen, it's sort of like penguins. You know how in Antarctica, all the penguins will be sitting on the edge of the ice floe, and they're just looking down to see if there are fish down there. But they're also concerned because there are sharks and things that eat penguins down there too. And so they're all looking, and they keep crowding each other. And eventually one of the penguins falls in, and the others look to see, did he get eaten? Then they all go in. So this is going to be like that. So we're hoping we'll find one penguin, and then the other penguins will happen, and then it'll be in all the browsers, because you don't want Edge to be the only browser that can do this, right? They're taking market share away from us, or at least visibility from us, so then everybody does it. And it should be an easy integration. And then I expect everybody is just going to be using the new modality where it makes sense. And nothing breaks. So I'm not proposing any change to the way that the web works now. So I'm not increasing the complexity of the current web stack. I'm not adding new modes which are going to introduce inadvertently new security vulnerabilities. Just providing a new thing, but providing in a way in which the audience does not observe that anything is different, except that it's faster and it works better. And that they don't need passwords anymore, because they can't remember the passwords, and they're always having attempts at tricking them into giving up their passwords. No more passwords means that everything gets easier to use. So the system is going to be based on strong cryptography. I'm going to be using elliptic curve 521 for key exchange, AES 256 for link encryption, and SHA-3. Now, there are lots of systems that had strong cryptography, but which were still very insecure. Having strong cryptography is no guarantee at all that you're going to get the security that you want. There are lots of other things which are even more important. But I'm using really strong cryptography here because I'm paranoid. We saw an incident last year where it was discovered that NSA had convinced NIST, what used to be the U.S. Bureau of Standards, to issue a cryptographic random number generator, which NSA knew to be insecure. That if you could observe enough random numbers coming out of this random number generator, you could predict all future numbers and also recover all past numbers, which meant that it was terrible for security. There's no security. And the federal government did that intentionally, which is really bad. So since then, we've been looking at all of the other standards, all the other cryptographic standards, looking at, have those been compromised? Do they have secret backdoors in them or something else? And it's been some years now, and we haven't found any yet. So for the moment, I'm thinking this stuff's still pretty good. And this is much stronger than we need, but I want it to be stronger than we need because I want to be able to go away without being compromised. You know, one of the problems we have in SSL is SSL has a negotiation where the browser and server negotiate on what level of cryptographic strength do we want. And that negotiation means that an attacker can choose, let's make it really easy. And SSL says, okay, that's fine. We'll make it really easy. So this is not going to give you the option. It's going to be strong all the time. A very smart guy named Zuko, talking about naming systems, said there are 3 important characteristics you'd like to see in a naming system, and you can never have more than 2 of them. So you'd like to have names that are meaningful to humans. You'd like to have names that are securely unique and globally decentralized, which means that there's no central authority which issues the name, that anybody can pick their own name. So one of these that the web chose was human meaningful. So, and it's arguable about if it really accomplished that, because that's what URLs are. A URL is the name of a resource. Are they meaningful to humans? Maybe with training, but not. So for my purpose, I'm going with the other 2. So I'm going to have names which are completely meaningless to people, in fact, extremely unfriendly and nasty and weird looking, but which will be securely unique and globally decentralized. That I need those characteristics in order to get the security that I want. And I'm going to give up the human meaningful thing and assume that we'll have software which will provide a nice face on this stuff so that the humans can manage it effectively. So I'm going to be using elliptic curve 521 public keys as unique identifiers. When you take 521 bits and base 32 encode it, you end up with a number which is 105 digits long, which is, humans cannot type 105 digits reliably. That's not going to happen. But they don't have to. Well, in the very worst case, like if you're in the underground and you need to do something, you're motivated, maybe you can type in 105 characters and get it right. So it's possible. But practically speaking, that's something humanity is not going to want to deal with. So we're going to have to provide other ways of making this friendly. But the proof that a public key is yours is the fact that you have the private key and you can decrypt messages which are encrypted with the public key. So it means there's only one secret we need to keep, and that's your private key. And your private key is also 105 digits, which means nobody's going to be able to trick you into typing in your private key. There's no way that's going to happen. So that exploit is completely fixed. There's no way someone's going to trick you into giving up your password. And a lot of the focus of our software is going to be in defending your private key and helping you to keep it away from everybody else. So we're not going to be using HDTP or SSL because I don't like them or trust them. Instead, we're going to be using secure JSON over TCP. Secure JSON has some very nice properties. One is that it's going to be much faster than SSL. We can create a secure connection in one round trip, that we don't have to do the extensive handshaking that SSL does, so we'll set things up very quickly. It's an asynchronous protocol, or a full duplex protocol, in that it's not a request-response. You can request, and responses can come back. In fact, the server can push. If the server says, here's something you need to know and you didn't ask for it, but here it is, we can do that. So we can do applications which are much harder to do over HTTP, because HTTP doesn't want to do any of that. It just wants to ask for something, wait, then send something else back. So And it's JSON, so anything you can send over JSON, it'll work. It will also have extensions in it to deal with blobs. So if you have just a big piece of binary stuff and you want to send that, that'll go over as well, and you don't have to do any trick encoding to it. It'll just say, here's a blob, and it goes. So this is what a URL will look like in this new scheme. So we'll have URLs of this format that you can put on the old web pages, and that will cause the helper app or the new mode to kick in, and it will go to the IP address that you indicate and establish a secure connection using the public key of that server. And you can also attach a capability, which is some secret thing that you want it to do. You know, maybe establish an account. So these are going to be really ugly URLs. The only piece of it that's attractive is the protocol. Right now I'm calling it web, because W3C didn't go with that. I don't know why. That's the obvious one, right? If you're going to create something called the web, what should the web protocol be? It should be web, right? Instead they went with this awful HTTP thing, which is confusing and weird. And also, we're getting rid of the // because that never made any sense either. So we're fixing that. So that part's really pretty. And I'm not sure I'm going to get away with the web part. At some point, someone's going to, oh, wait a minute. So I'm prepared to call it something else. But for right now, because nobody else wanted it, I'm going with web. And then you've got the 105 characters in the public key. Then you've got the IP address, which is, if it's the new kind, it's going to be 8 5-digit numbers separated by colons. That's pretty nasty, too. So I don't expect humans ever type this stuff in. So the way this might happen is you go to your bank, and your banker gives you a card with a QR code on it, which encodes this. You say, scan this into your device, and you now have a link. You are now linked to the bank. We now have a relationship, and you will never need a password, and you will never have to worry about being directed to something that looks like it's us, but it's not. Guaranteed, you'll always connect to us. It'll always be secure, and everything's good. Really easy. Another way this might work is you want to connect to somebody, and you want to do it securely. Where do you go? You go to Google, right? And Google will give you the page which most likely is the thing that you want, and it contains one of these URLs, and that takes you to the thing, and you're good. Or a company might want to put their thing on billboards in some public place, and you just go and look at it and go click, and you're in. So there are a lot, or you can put it in magazines. They still have magazines, right? So you could just put the QR code in your magazine, which encodes this, and it's good. So there are lots of ways we can distribute it. They can be distributed in email, although that's less trustworthy currently. I'm hoping that when we get this system up, someone's going to rethink email and say, well, if we have this protocol, this is how email should work, and spam goes away forever, and all that stuff goes good. So it's ugly, but we can manage it, and we can hide it. And then the application itself provides trust management. So you can give your own pet names to these things and say, I want to go to my bank, and it'll go to your bank, and no one can confuse you, and it's really easy for you, and we'll manage all of this stuff. And we'll also keep all of your relationships in the cloud in a very secure way so that all of your devices will know how to do this stuff. Now, one thing that changes is, we're talking about trust management. The way you think about, what does it change? Lost it. Couldn't have been important. Anyway, the programming model is all about VATs. In the browser, everything was about one common global space. Everything plays in there. That turns out to be really bad. So a VAT is a module. It's a container in which you can run some stuff. It's very strong. It's much stronger than a sandbox, because sandbox leak. And if you have a cat like I do, you don't want a leaking sandbox. And so we can put code into a VAT, and it can run in the VAT and do all the computation it wants. And if it needs to affect somebody else, it can't go and change their variables or even call their functions. All it can do is send a JSON message to them. So we can have lots of VATs in the same machine. and each VAT will represent the presence of some site or some interest, and they can communicate with each other, they can cooperate with each other, but they cannot compromise each other. All they can do is exchange messages. And that is good enough. We can build secure systems with that. So we're going to have to repair a few things in JavaScript in order to get that kind of containment, but that's something we know how to do. In fact, a lot of the improvements that were added to JavaScript for ES5 were specifically to make this easier to do. So having VATs that can communicate gives us cooperation under mutual suspicion. So that allows us to have mashups that are effective and secure. So we can have multiple parties all running in the same application, all working together cooperatively for the benefit of the user without any of them being able to get over the other. And that's something that we need, and it's something that the current web cannot do. So this is a block diagram. It's a really simple block diagram. So we've got two components in this. The first one is a JavaScript message server, probably Node. Anybody heard of Node? Everybody? Yeah, Node's great. So we're going to be using Node as the thing that runs our VATs. So all the VATs will be running in Node, and Node will provide the file services and the network services and the JSON messaging system. Now, Node was not designed to be a secure system, so we're going to have to take a hard look at it, and there may be some things in Node that we're going to have to remove or modify in order to get the security requirements met, but we don't think that's going to be too hard. There are a few things that are Node that I want to take out anyway, like the sync functions, those got to go. And we may want to change the way we think about file I/O entirely because we want to get into a capability system. Then the other component is Qt. Qt is, anyone familiar with Qt? Yeah, it's not so well known over here, but it's brilliant. It's an application delivery system that was developed in Norway by Norwegians, very, very smart guys. It was part of Nokia for a while. It's now open. It is very powerful. It uses JavaScript as well. So we're going to have Qt VATs, which have display and interactivity, which can send JSON messages to the Node VATs. So Node cannot get to the display. Qt cannot get to the network. We'll finally get correct partitioning of concerns in our applications, and it'll be forced by the model. So you can't do the stuff that happens in the web right now where everything is kind of everywhere. We're going to have good compartmentalization. One of the nice things about Qt is that it's hardware accelerated, so you get down to the hardware, and the GPUs will let it go very fast and efficient. And it's a really good programming model. It is so much better than what the DOM provides to you. So it should be pleasant for making stuff, and we can have VATs representing the multiple interests all on the same page, and they cannot cover each other, they cannot clickjack each other, they can't do any of that stuff. They'll just be able to cooperate, and that'll be a really good thing. So I'm not proposing getting rid of the old web because it provided a really valuable service, which I describe as promiscuity, that you can relatively safely go and connect to things that you have no idea what they are and probably will not be hurt by it. And that provides for introduction and discovery and lots of really good stuff. There's a lot of good public service and things in it. But it's terrible if you have committed relationships. You can't have good commitments in a system that only does promiscuity. And so I also want the new web because it's all about commitments, that you cannot casually connect to something in the new web because you need to have its IP address and its public key. So that means you already know quite a lot about it before you decide to connect. But it means that every time you connect again, you're getting to the thing that you thought you were going to. And that is something that the web can't do. And we need both of them, right? So the old web will continue to exist. It'll be the analog channels. As long as someone's watching analog, it'll be there for us. And the new stuff, the critical stuff, the stuff with money flowing in it, the stuff with secrets in it, that's going to want to be in the new web. And the two will live together compatibly. And while you will notice a huge difference between the two the audience will not notice any difference at all, except that the new web doesn't ask for passwords ever, and it runs a lot faster and maybe looks better. So there's nothing new here. The security model under all of this stuff is called object capability systems, and it's been around for decades. I'm just taking these ideas which have been proven and putting them into a mode in which I think we can successfully transition into the web. And if we can accomplish that, it means we all now have a new set of options, a new set of tools that we can use for doing our work. So in the meantime, keep doing what you're doing. I'm not proposing that you stop doing anything that you do now, that you not change your plans, because I can't tell you when this is going to happen. My intention is that this happens soon, and it's going to be great, and it's all going to be open, and you can all share in it, and we'll all do it together. But I'm not to that point yet, and so I can't say any of those things. I can tell you what my intentions are, and I can also tell you that the intentions of a programmer are completely worthless. Like, when are we going to get this done? Well, this shouldn't take very long, right? It's my intention that we get this done right away. And it doesn't usually happen. So it'll happen when it'll happen. And so there used to be this thing called FUD. Anybody remember FUD? So FUD was invented by IBM. There was another company called Control Data, which made a brilliant computer called the 6600. It was the fastest computer in the world. And IBM didn't have anything like it. And they were starting to lose sales to Control Data because they had the world's best computer. And so IBM announced that they had one too. And it was coming out soon, so don't buy that one. And that hurt CDC really bad. So they took IBM to court, and they won. And IBM had to give them millions of dollars, and but they kept doing it, and Microsoft has done it. There are lots of companies who, when faced with a competitive thing, will lie about having new products, and it's called fear, uncertainty, and doubt. You try to corrupt the sales environment so that people will not buy your competitor's thing. That is not what I'm proposing. I'm telling you, keep using the web. Keep doing everything that you do now, because I got nothing to give you. But what I am offering is maybe hope, that I'm hoping that someday we'll have a new set of tools, and it'll all be open, it'll all be free, and all be wonderful, and it'll all be good for us. That's my intention. And maybe the next time we meet, I can give you some more specific information about where that's going. But for right now, again, I apologize. I have nothing. I have nothing to give you. And I am very sorry about that, but that's sort of... But I intend that... Anyway, but I got nothing. So that's it. So until next time, please keep calm and JSON. Thank you and good night. So do we have any time? We've got 5 minutes, so we could do a couple of questions. So anybody got a question? Yes.
I was wondering if you could make any comment on, like secure JSON over TCP, and how that would compare against like fielding REST and his posse of believers that that's the best way to scale. Any thoughts on that?
So he's asked me to compare secure JSON over TCP with REST and all of that stuff. I never understood REST. It never made sense to me. REST looks to me like a distributed object system in which you create all of your classes with only 6 or 7 verbs, 6 or 7 methods which describes everything, which seems really unnatural to me, that he took some aspects of a bad transport protocol and said, and we're going to use that for everything. And it's got a lot of worshipers. You go to the REST church, and it's full of people. And I hear them singing the songs, and I just don't understand it. I don't know if I answered your question. Anybody else? Yes?
You kept saying we a lot. Is there an actual team working on it?
There is an actual team working on this. So I work at PayPal. PayPal has been very kind in giving me some very smart people who are actually doing the work on this stuff. And I'm hoping, or my intention is that they're going to deliver some really good stuff. Yes?
Yes, you mentioned the use of a QR card to make new URLs. So what prevents people from giving you, like, I guess, hacked QR codes or, like, QR codes to, like, dark sites?
So what prevents people from giving you hacked QR codes? Nothing. But, because anybody can create anything, right? And if they can trick you into using it, then something happens. But suppose someone's pretending to be your bank. So there are bad things that could happen from that you might think that money has been transferred into your account or transferred out of your account, and it isn't because you're not actually looking at your account. But they're not actually getting your money, and they can't get your password. They can't get access to your account. So they can confuse you. So you can imagine some Mission Impossible sorts of scenarios where that's of benefit, but that's the most that they can do. And we can provide verification services which help prevent that. But ultimately, if you trust the wrong people, bad things are going to happen. But it's going to be much easier to verify that things are the thing that you want to trust. And the consequences of trusting the wrong thing are much less severe than they are in the current web. Now, if you want to talk about potential compromises of the system, the thing that I'm most worried about is how well can we protect the private key. So one thing that I'm hoping for is that by the time we're ready to deploy this to the public, we will have made some discoveries in biometrics. Because if you have a device that's got your private key in it, I want it to shut down when you are no longer in control of the device. Like if someone takes it from me, I don't want them to now be able to get access to everything that I have. Right? I want it to shut down. So I want our devices to get a lot smarter, and I'm not going to solve that problem, but I'm hoping that someone else is going to solve that problem. So we have seen work in trying to identify or replace logins with some kind of thing, where a fingerprint or something, but that's not good enough. I want to know every second who's in control of this. And maybe there's a camera that's looking at me, and when it sees that I'm no longer on the screen, it shuts down or whatever. I don't know. Or maybe there are lots of ways it could work, and I don't care how it works. I just need something like that. I'm also concerned that the browser, if the browser has bad stuff in it, can compromise us. And the operating system, if it has bad stuff in it, it can compromise us. And I'm really concerned that we don't have secure browsers and we don't have secure operating systems, and I think that's appalling and intolerable. But that's the state of the art right now. So it's possible to get under us and do bad things. I hope to fix that too, but that's another talk. So we're out of time. Have a great conference, everybody. See you later.